Second equation, derivation, integral b dot ds. This is the integral form. Integral b dot ds equal to 0. And the differential form is div b equal to 0. So from here we will derive this derivation of the second Maxwell's equation. Consider this integral form. This is the integral form. Surface and volume integrals can be equated. So equate this to the volume integral dv. From ds it is changing to dv. From here, according to Gauss divergence theorem, that is. Since this is 0, the right hand side is a 0. This del dot b is a 0. That means the div b is a 0. And that is what exactly we want. If you come here, div b equal to 0 is your second law. We started with b dot ds. So here we just in the derivation have to use Gauss divergence theorem to equate surface integral to volume integral and make this 0, and therefore hence it is derived. That is your second Maxwell's second equation. Now the third equation of Maxwell. The third equation of Maxwell is integral E dot dl is minus dou phi b by dou t. This is the integral form. Now, this can be written as minus d by dt integral b dot ds, surface integral. Or minus dou b by dou t. This dou by dou t is taken inside of dou s. Applying Stokes' theorem, equate line integral to surface integral. Integral E dot dl is equal to surface integral of del cross E dot ds. This is according to theorem. This is EDL, this is EDL, equate these two. You get this. Now, that is del cross A. Again, when you cancel ds on both sides, you have del cross A equal to dou b by dou t with a minus sign. Del cross is nothing but curly. Minus dou b by dou t. So your third law is derived. From the differential form, from the integral form to the differential form. It is different. Curly can be expanded and written like this, or you can stop it here and say curly is minus dou b by dou t. Coming to the fourth equation. This is the fourth equation of Maxwell. Integral b dot dl is mu 0 I. Use Stokes' theorem, line integral is equal to surface integral. So over the surface. This can be written this way. This is from Stokes' theorem. Now del cross b dot ds is equal to, see, in place of b dl you are writing all this. Mu 0. I is written as integral of the surface j dot ds. From here del cross b, when you take mu 0 inside, is mu 0 j. And this is your fourth equation, Maxwell's fourth equation. So from the integral forms we have derived the differential forms, that is both represent the same thing.